Okay, ladies and gentlemen, good morning. In today's video, we are going to look at the concept of permutation and combination, that is mathematics. And don't forget to please follow and subscribe my YouTube channel. So let's start with the permutation and combination. Permutation and combinations are the fundamental concept in combi. It's actually they are fundamental concept in combinatorics. That is combinatorics. These are two important uh, parameters that are very important in combinatorics, and we are going to look at their meaning and their applications in real life in this video. So this permutation and combination, they are used to count the arrangement and the selection of objects. So we use the permutations and these combinations to count the arrangement as well as the selection of the object. So usually we use permutations to arrange object, while combination is used for the selection of an object. You may be given a thousands of an object, and to select them, it is the best way to use combination. And of course, if you select them, of course, in terms of the arrangement of the object, you can use permutation to arrange the objects. So in addition, this is actually the formula that I use for the calculation of permutation and combination. So the number of permutations, usually the order matters. That is how you arrange the objects, it matters. So we have the formula for calculating permutation, P into N R. The N represents the factorial of an object, that is the number of the objects. And then we have R, that is the number of the objects taken at a time. So you have N as a number of the object, while you have R as a number of the objects selected at a particular time. And then we also have the number of combination. So in the case of the number of permutation or permutation, the order of the arrangement of the atom is matters in case of permutation. While in the case of combination, order does not matter. So here you have N, that is the number of the objects, and then R, the number of the objects taken at a time. So that is why we have C, capital C indicate combination. So combination N of R is equal to, we have a formula, the factorial of N all over N minus 1, N minus 1, we have N minus 1. You can see we have N minus, N minus R factorial, then we have R factorial. So this is actually the formula for calculating combination. And then in addition, we can have also the number of different permutation of an N object where there are N1 repeated items and N2 repeated items and up to Nk. So at that situation, you use this formula. That is, the number of different permutations can be used as N factorial all over N1 factorial, N2 factorial, and then we have Nk factorial. So this is how we use a formula for calculating number of different permutations. So then you see we have a formula for calculating permutation, which is N factorial all over N minus R close bracket factorial. And then for the combination, we have N into NR. Then we have equals to N factorial all over N minus R close bracket factorial. Then we have R factorial. So of course, in this video, we are going to look at the different examples. So then the next thing, ladies and gentlemen, we have apart from this formula, then the next thing that we are going to look is, of course, understanding this concept is essential for solving probability problems. So you know that we have probability in mathematics. So if you are able to understand the concept of permutation and combination, it is really help in solving problems in probability. So then now we are going to straight to the definition of permutation. So what is permutation? A permutation is an arrangement of objects in a specific order. So therefore, in the case of so file mutation is an arrangement of an object in a specific order. So when we are talking about how you can arrange an atom, how you arrange an object in a specific order, so that is what we call a file mutation. You may be given actually a set of numbers or a set of letters or a set of an object, and it is through the use of this permutation that you'll be able to arrange the object in a specific order. So the order of selection matters in permutations. So you have to know the order of the selections, how order you select your object. It is very important in permutation. So now, for example, let's say the arrangement of letters. So you have a set where you have letter A, B, and C. So this letter A, B, and C, they can have actually different permutations. So let's look at the possible arrangement of these letters. So sometimes, ladies and gentlemen, to know the number of the arrangement is simple. Count the letters. The letters are three. So since the letters are three, you can just say three. Since the letters that we have here, there are three. So it is actually very much more easier know the possible number of the arrangement of these three letters. So how do you do that? Then to know the arrangement, you can just say 3 factorial. So when you say 3 factorials, what does that mean? 3 factorials means 3 times 2 times 1. Remember our previous video on factorial. So therefore now we have 3 times 2, we have 6, 6 times 1, we have 6. So it means that there are 6 possible arrangement of letters A, B, and C. And what are the arrangements? Let's see how we can arrange letter A, B, and C into 6 different arrangements. So you see we have first, we have A, B, C. We can have A, C, B. So you see you started with all letter A. So what if you start with letter B? We can now say we can have C, A, B. We can have C, B, A. So you see, this is also another possible arrangement. So you can start with letter B at the same time. So you can now say C, A, B, and then we can now say C, B, A. So these are the 6 possible arrangement of letters A, B, and C. So in a permutation, it is actually one of the mathematical parameters that use in arranging numbers or letters in order. So this is to show you these are the possible ways that you can be able to arrange letter A, B, and C. So you can arrange them in 6 ways. So if you are given a particular set of an object, so the first thing I think to do is to calculate the possible number of arrangement. So from there, then you can arrange them if you are asked to arrange them. So here we have the following letters and we want to see how we can arrange them. So we can arrange them in 6 possible ways. And that is why we also go ahead with this arrangement. So you can see, ladies and gentlemen, clearly from here, because I already have it in the PowerPoint. So you can see clearly here, these are the 6 possible arrangements where we have ABC, we have ACB, we have BAC, we have BCA, we have CAB, and we have CBA. So these are the 6 possible arrangement of the letters. So then the next thing, the formula. What is the formula that is used in calculating permutation? So the formula for the permutation of n object, that is n represent the number of objects taken R at a time, that is R indicate the number of the objects taken in the given sample, so or in the given object. So therefore you can now use permutation of n of R is equal to n factorial all over n minus 1 factorial, as I described previously in the first slide. So here n factorial represents the factorial of n, which is the product of all positive integers up to n. And if you want to understand this, watch my previous video on factorial of a number. So then the next thing, this formula helps calculate the number of ways to arrange the subjects to arrange a subset of object from a larger set. So you can be given actually a larger set. So when you are given a larger set, you may be asked to calculate the number of ways that a particular subset, that is some element from that particular object, to be arranged. So let's see. So this is the formula. We have, of course, we can see we have a factorial, that is n number of factorial of r, that is np of r, is equal to n factorial all over n minus 1 in bracket factorial. N means the total number of objects, then r means the number of objects chosen at once. So therefore, n is less than or equals to r, and r is less than or equals to n always. So now let's look at some examples. So if you want to arrange 3 books out of 5, you will use the permutation formula. So let's say you have 5 books and you select 3 out of the 5, and you want to see what are the possible way of arranging 3 books out of 5. So let's say actually you are in the laboratory and you have, in the library, you have 5 books, and out of the 5 books, you choose 3 out of the 5, and you want to see what are the possible way to arrange those 3 books. So you use actually a permutation formula, which says P of n of r is equal to n factorial all over n minus r open bracket factorial. So therefore, we now have the n factorial. We have 5 factorial divided by 5 minus 3 factorial. So how do we do it? So we have 5 factorial is the same thing as, of course, is the same thing as 5 times 4 times 3 times 2 times 1 divided by 5 factorial minus 3 factorial is the same thing as 2 factorial. So 2 factorial, it means now we have 5 times 4 times 3 times 2 times 1. And then for the 3 factorial, we have, of course, we have 2 factorial, we have 2 times 1. So therefore, this one will take care of this. This 2 will now take care of this. So we are now left with 5 times 4 is 20. 20 times 3 is 60. So it means that there are 60 possible ways to arrange the 3 books out of 5. So this is the permutation of 3 books out of 5. So this is actually the first example for this. So I think, ladies and gentlemen, we are going to look at, we are going to see more of the examples. And ladies and gentlemen, let me tell you something very important. Apart from formula for calculating, apart from this formula for calculating factorial of a number, we also have a formula for calculating permutation when you have a repetition, of a number. So a repetition of a letter or repetition of an object. And that formula is n. The formula is n power r. The formula is n power r. This is the formula for calculating possible arrangement of a particular subset from a set of an object with repetition. And this one is used without repetition. This one without repetition. While this one is used for when there is repetition, that is with repetition. So this one is used when there is repetition, and the other one when there is no repetition. So n power r. So let's look at the further examples here for the permutation. So you see how we were able to calculate the possible number of arrangement of the following. So I think without wasting much of our time, ladies and gentlemen, let's look at the calculation. So the calculation will be P into 5 comma 3 is equal to 5 factorial all over 5 minus 3 factorial would give us 60, as we have shown, or as I have shown from the example. So it means that thus there are 60 different ways to arrange 3 books from a selection of 5. So now we have another example. How many 3 letters word with or without meaning can be formed out of the letters of the word swing when repetition of the letters is not allowed? So you see, since the repetition of the letters is not allowed here, so you apply the same formula, which is, of course, as I said, factorial of a number. Let me actually show how it is going to be. So we have permutation is equal to, now we have the number of, okay, so let me see how many 3 letters with a or without meaning can be formed out of the letters of the word swing. So let's see how many words do we have in swing, how many letters we have in swing. We have 1, 2, 3, 4, 5. So we have 5. So here it means that we have 5 factorial divided by, of course, 5 factorial. Okay, sorry. Before that, we have 5. So we have 5 minus 3 open bracket, close bracket, factorial. And this will give us 5 factorial divided by 2 factorial. And don't forget, it's almost similar example. So 5 factorial divided by 2 factorial is going to give us 60. So this is without repetition. So let's look another example. How many 3 letters words with or without meaning can be formed out of the letters of the word smoke when repetition of the word is allowed? So you see, when repetition of the word is allowed, so we count the number of letters. So we have 5 of them. So we have 5 letters. And of course, remember, if it is with repetition, we use n power r. So our n here is 5, and then the r, the number of letters selected at once. So therefore, we have 5 factorial, which is 125. So with repetition, we have 125. So ladies and gentlemen, this is actually permutation. So in the next video, we are going to look at the concept of combination. So ladies and gentlemen, please don't forget to subscribe and join to my YouTube community. See you next, and bye-bye.